Hi guys, you are welcome to your C++ platform where we teach you how to program in C++ using the step-by-step do-it-yourself approach. I'm IK Intin, your tutor on this platform. Today, the objective of the study, what are we seeking to achieve at the end of the day? At the end of the day, we seek to introduce you to the types of operators in C++ and their implementation. Again, we also seek to help you to understand operators precedence in C++. So, what is an operator? An operator is a symbol that tells the compiler to perform specific mathematical and logical manipulation. So it tells the compiler or gives the compiler an idea on the type of mathematical operating the user seeks to perform. So the C++ has a lot of these operands and operators, have a lot of these built-in operators that provide the following. It helps us to do mathematical operation using the mathematical operators, relational operators, logical operators, bitwise operators, assignment operators, and we have the mixed operators. So in this tutorial, I'll be taking you through the arithmetic operators, the relational operators, the logical, the bitwise, assignment, and other ones also. So what is the mathematical operator? These are the mathematical operators we have in C++. I believe that we've all seen these operators before, with the exception of one or two that are new. For the addition, one with the addition stands for adding two numbers. Subtraction stands for subtracting the second number from the first number. So we have 5 minus 2, that means that we are subtracting 2 from 5. Then we have multiplication. Then we have what? Division. Remember that in C++ we don't have anything like we don't have any symbol like for instance multiplication like this. We use what? The asterisk. So if we want to multiply, it's the asterisk that we use. And then we don't also have any division like this. We use this as well, division. And then we have what? The modulo or the percentage sign. We call it the modulo operator, and remainder of after any integer division. What do we use it for? We use it when we are interested in the remainder of integer division. For example, if let's say we have 5 divided by 2 and we are interested in the remainder, in this case 5 divided by 2, the remainder is of 1. So if we want to get the remainder of any integer division, then we use what? The modulo. Then we have what? The incremental operator, plus. That what it stands for is that it increases integer value by 1. So if we have say c is equal to 5, and I come and write c plus here, what it means is that c is now equal to 5 plus 1. Are you following? So it increases an integer value by 1, and the decrement operator also decreases an integer value by 1. So it's a vice versa of the increment operator. So we have done some implementation. We urge that you copy these codes into your compiler and run them also and see what is happening, and then you can appreciate what is going on with arithmetic operators. So when we ran it, we had initially the value of k was 10 and the value of I was 2. So k plus I here will be 12, 10 minus 2 here will be 8, 10 times 2 here will be 20, and 10 divided by 2 here will be 5, and here 10 modulo 2 will be equal to 0, because why? We said that we use the modulo when we are interested in the remainder. So we have 10 divided by what? 2. Sorry, 10 divided by 2, which is equal to what? 5, remainder what? 0. And that is why you see that here is what? 0, because the remainder of this division is what? 0. Then here we have k plus plus. So what is the value of k? The value of k is equal to what? The value of k is equal to 10. So k plus plus we said is equal to what? K is equal to what? K plus what? 1. That is the mean. So here will be 10 plus 1, and that will be as what? 11. Are you following? Then so after this, the value of k is now 11. So if you say k minus minus, it means that 11 minus 1, because the value of k after this equation here has been increased to what? To 11. So 11 minus 1 is what? 10. Then we have relational, that we have the double equal sign that checks if the value of two operands are equal or not. So if I have, let's say 5 and I have what? 6, I can use this to check if this 5 is equal to 6. So if I say 5 equals 6, I'm saying that it is whatever is on the left hand side here, is it the same as what is on the right hand side? Then we have the not equal, checks if the values of two operands are equal or not. If values are not equal, then condition becomes true. Then we have the greater than sign that we all know, the less than sign. Then we have what? The greater or equal to. Remember that in mathematics they write it this way. Yes, C++, this is equivalent to this. So if I want to write greater or equal to, I'll do it this way. And if I want to write less or equal to, then this is how we implement it in C++. So let's see some relational operation on these two integers. We have int a equal 10 and b equal 20. So here we are asking that is 10 equal 20 and 10 is never equal 20, and that is why here it is not true. And here we are saying that 10 is not equal 20, and that is true because 10 is not equal to 20. And here we have 10 is greater than what? 20, which is not true. Then we have 10 is less than 20, which is what? True. And then here we have 10 is greater or equal to 20, which is not true. 10 is not greater or equal to 20. And here we have 10 is lesser or equal to 20, which is what? True. So we go to logic operators. So the logic operators, we have the and, we have the or, then we have what? The not. So we have the and. The and operates like, remember the and gate, and gate. If you have learned at and gate before, where we have this, and gate. We said that what? If here is equal to P and here is equal to what? B and here is equal to F, then we said that what? F will be equal to 1 if and only if A and B are equal to 1. Don't forget. Then we have what? The OR gate. Remember we used to have OR gate, which is like this, and then we said that the OR gate, what do we say? We say OR gate if any of the input is equal to 1, then the output F is equal to 1. The same applies here. Then we have the NOT, which always turns the logic output to be, or reverse the logic output. So if we have 1 as the output, the NOT will reverse it to 0, and if 0 as the output, the NOT will reverse it to 1. We have the bitwise operators, which remember that it's bitwise, so they operate on bits and they perform bit by bit operation. So let's take example here. We have the I, which is equal to this, and we have for J, which is so IG, that is I and J, so it's like AND gate. I or J is like OR gate, and I XOR J is like a XOR gate. So let's do this more complex one here for you to understand what's actually happening here. So let's assume that we assign A to 60 and B to 13, which 60 is equivalent to this in binary 2, and this one is equivalent to this in binary. So now we have A and B. So what is it happening? It's happening that we multiplying this and that. We are working 0 and 1. So 0 and 1 is what? 0. Then we have 0 and 0 is what? 0. 1 and 1 is what? 1. And 1 and 1 is also equal to 1. So that is what is happening. Literally, if I say literally, it means that unofficially, we can assume that AND gate is a multiplication, and OR gate is addition. Literally, let's assume that. So with that in your head, it might help you. So here is OR. So we have 0 plus 1, which is what? 1. 0 plus 0, 0, 1 plus 1, 1. You can't say 1 plus 1 is 2 because this is base 2. Then we have what there is all. Then we have what. So you can go through and then you will follow what is happening with the bitwise operation. So in C++, these are the bitwise. We have this, we have the AND, we have the OR, we have the XOR, of which I mentioned already. Then we have the binary ones, and then we have the binary left shift, we have the binary right shift. All these ones are implemented, and the explanation here will give you better understanding into it. Now, of course, we will do illustrations step by step, code them, and then to see what is happening. So an implementation of the bitwise operation is what we have done here. So as you can see, we have assigned k, unassigned int k, and unassigned int I. We have int c. So what are we doing here? We are saying that k and I, here is k or is or that. So copy this one and put your compiler, run it, and then you will get this output. See, all these ones are necessary for us to go through, because in subsequent videos we'll be using some of these operators, and you might ask what is the essence of this one. So you need to understand and familiarize yourself with it. So I will urge that you code them, run them, and see what they have to play alongside, and then do more with it. So we have the assignment operator, that is the equal to that we use to assign. So when we say equal to, let's say we say C is equal to A plus B, we'll assign the value of A plus B to C. So when we use the equal to, we are putting what is on the right hand side into what is on the left hand side. So it's more or less put what is here to here. That is it. Then we have what the add and assignment operator. What is the meaning of this? So let's see, if we write this in C++, what does it actually mean? If we say we have C plus equal E, what does it mean? It means that C is equal to C plus A. So instead of writing this, instead of writing C is equal to C plus A, we can just write this short one here, and it means the same thing. So we have the minus equals, that is subtraction, and assignment. So it's also the same thing. So if we write C minus equal E, what do you mean? You mean that we want to write C is equal to C minus A, but we see this one as a longer way, so we just write this one same as this, it works in C++. You can go through the rest, and I've explained here what they are meaning and what they imply. So take your time and then go through all these ones. Their meanings are all here. And then if you have any question, don't hesitate to send me a message and I will answer it. So this is the implementation of it. We have implemented the assignment operator. We've done implementation of it. Go to the implementation, copy it, and put it into your compiler, run it, and see, check your output with our output, and then understand what is going on. And if you have any question, you call us, or you send us an email, or you give us a comment on our YouTube channel, and we will be glad to help you out. So we have the finish word operator, where we have the size of the operator that returns the size of a variable. So if you want to know the size of a variable, we use that one. And then we have the condition operator. If condition is true, then return a value of x, otherwise return a value of y. So we can use this one like if else statement somewhere. Then we have the dot and the arrow. That's member operator are used to reference individual members of a class structure and union. So then we have the cast that we use to how do you call it, convert one data type to another. Then we have the pointer operator and return the direction of a variable. Then we have what the pointer operator, it points to a variable. So all these ones here, we want you to know what they are, so that when we are using them in the subsequent videos, you will not ask yourself, hey guys, I can't find my way out. So just go through and familiarize yourself with it. And as I've always saying, if you have a question, don't always don't hesitate to let us know. Okay, so we have what operator precedence. So these operators, if we have 1, 2, 3 of them in a same expression, how does the compiler evaluate which one comes first or before the other one? So like normal, like when we're doing maths, remember board maths, bracket first, of those ones. So operators precedence determines the grouping of terms in an expression. This affects how an expression is evaluated. Certain operators have higher precedence than others. For example, the multiplication operator has a higher precedence than the addition operator. So if you have something like this nature to process, we give this to the C++ compiler to execute this one. Right? It will tell us the answer is 30. Why? Because it's going to solve this one first. 2 times 3, which will give you 6. 4, that's the addition. 7 plus what? 6, which will be equal to 30. So if it is postfix operators, this one. So if we have the parentheses here, we have the square, we have the dash arrow, we have the dot, we have the plus plus, and finally. So this is what we are saying, that this is how they follow. It will first look at the what comes here. And if it's unary, it will look at this, look at that, follow the same way. And if there's multiplicative, it's going to do it this way. And that also follow additive. So take your time and just go through and then familiarize yourself with them. So here we've done implementation of the precedence. So what we have done is that we declare some initial values, integers here, giving them some initial values, and then we have implement a lot of this precedence here to see what the output will be. In fact, I will urge that you copy this one into your compiler and run it. But first, try and remove all these parentheses. Don't put them here, and run them and see the output, and again put the parentheses and run and see. I want you to see what happened, what role that this parenthesis also plays here. So when we run this code, this was the output, and then you can also copy it and run it and check with our output. We thank you for watching this video. We appreciate you watching. Our next video will look at loop types. We're going to look at the for loop, the while loop, the do loops, the if, the else if statement. We're going to look at all these. People also call the control structures. We're going to look at them. We urge that if you're interested in our videos, please guys try and subscribe to our channel and be the first to know when we release any video. Stay tuned and be blessed. God bless you for watching, and share the video with your friends. Thank you.